Hello. Today we're going to be discussing covalent bonds and compounds. We discussed ionic bonds and how ionic bonds give up electrons and give up or gain electrons to form their compounds due to the force of attraction between the negative and positive charges. So today we're going to discuss the covalent bonds. It's slightly different because covalent bonds aren't giving up electrons per se or taking electrons. They're actually sharing electrons. Okay. So covalent bonds and compounds are when atoms share a pair of electrons. So two electrons are shared, and what they do is they spend time around the nuclei or the nucleus of each atom, okay, or the nuclei of both atoms. They're usually formed between two non-metals. Okay, so what you'll see is, and we'll talk about it in a second, is you'll see that like carbon and oxygen and nitrogen and oxygen and all sorts of nonmetals, hydrogen and oxygen, where you find water or hydrogen peroxide, which is H2O2. Okay, you'll notice that covalent compounds are very similar in the fact that they are made up of nonmetals, whereas the ionic compounds were made up of both a metal and a nonmetal. Okay. Examples include carbon dioxide, as I just said. Okay, this is carbon dioxide. Okay, sugar or glucose. Okay, get familiar with this because in the future, when you take biology or the living environment, there's going to be a large amount of time dedicated to this and the process of photosynthesis. Plants actually take carbon dioxide and water from the environment and create this sugar called glucose. And we'll discuss it more in a future vodcast. But you'll see that if you look carefully, carbon dioxide and water, all right, have the same elements in them that sugar does: carbon, hydrogen, and oxygen. Okay, and then you have water. You should be pretty familiar with it as we've gone over it many times this year. Now, the key component of a covalent bond versus an ionic bond is that covalent bonds, as I said, share electrons. Okay, they share electrons. Oops. All right, didn't mean to cross it out. All right, they don't gain or lose electrons as in ionic bonds. This is ionic bonds. All right, they share the electrons. So, like I said, the electrons spend time around the nuclei of all the atoms in the compound. Okay. Now the models are slightly different too. All right, you have a bunch of different models. You'll see this is how we draw up a covalent bond models. Okay. This is really your Bohr type model. Okay, looks very similar to a Bohr diagram, right? So you see the two hydrogen atoms, and basically what's happening is these electrons are spinning around. Oop, you can't even see my pen color, so let me change that. Okay, I'll go to red. It's easier to see on the. So you'll see that these electrons actually, oops, of course I picked green instead of red. These electrons are kind of spinning around both nuclei of these atoms, okay? And you'll see the fluorine atoms. Remember, fluorine needs one electron to fill its outer shell. So the fluorine molecule shares those two, all right, and they spin around the nuclei equally. Okay, and you'll see the CO2 molecule here. All right, so you have the two oxygen atoms, and carbon needs to fill 1, 2, 3, 4. So it has 8. 1, 2, 3, 4, 5, 6, 7, 8. And you'll see that an oxygen needs 2 to fill its outer shell. So what happens is the molecules go around, okay, and they share those electrons between them. Okay, I'm just going to go back one and then go back here. Now, what you'll see sometimes is you'll see it drawn as a stick model, and I'll show you that in a couple of seconds. But hydrogen in the stick model, we drawn like this, okay? And this line indicates that 2 electrons are being shared. 1, 2. Okay? So if you were to draw fluorine, it's very similar to the hydrogen there. Okay? You're sharing these 2 electrons, right? So each line indicates that a pair of electrons is being shared. Okay, so if you're going to draw this one, okay, you would draw it as CO2, realizing that, okay, you're sharing those. You do the yellow electrons here and the purple ones here. Okay. So you'd have 2 lines there. So I'll just draw that again. See, that's the stick diagram for CO2. Okay. Now, what you'll notice is I just showed you that carbon, hydrogen, and remember, hydrogen is the exception to the rule. It's not really attached here at the periodic table. It is separate because it is a non-metal. It belongs over here with the rest of the non-metals, but because of its atomic structure having only 1 electron in its outermost shell, they put it in group 1 with the rest of the atoms that have 1 electron in the outermost shell, which we call a valence electron. Okay, so you have CO2, H2O, C6H12O6. You have the fluorine molecule. Okay, and now realize that if you have a fluorine molecule, chlorine acts very similar to fluorine because of its atomic structure, and so does bromine and iodine. Now, one of the things many people get confused at is the symbol Cl. All right, this is a lowercase l. This is chlorine. Okay. All right. Many times you will see it, and some people get confused that it's iodine, but most of the time it is chlorine. Okay. So covalent bond models. There are several different ways that you can show a visual representation of a covalent molecule. Okay, we said the ball and stick model. And in this model, each line in a ball and stick indicates that 2 electrons are being shared. Remember, we showed you that before. So there's an electron here, an electron here being shared, an electron here, and an electron here being shared. Okay? And there it is again. That's your standard water stick model, H2O. Oops, I'll draw the O bigger. Okay, let's erase that. Okay. Okay, and here's another organic compound of carbon and hydrogen in the ball and stick model there. Okay, so covalent bond models. We talked about the dot diagram. Okay, you could draw it as a stick model or a dot model. Okay, this is the Lewis dot structure. This is why we covered the Lewis dot structure. Remember, Lewis dots represent Lewis dot structures or diagrams represent valence electrons. Okay, so it's only talking about the electrons in the outermost shell. So if you remember, chlorine's a halogen, so it's in group 17. It has 7 valence electrons. Okay, so what happens is it needs to fill 1 spot in its outer shell. So what they do is they share a pair of electrons. It can be written like this. If you remember or you can see it's written with the dot structure or with the stick structure, the ball and stick structure, except it's also indicating the valence electrons as well. Okay? Now, there's also another type of covalent bond called a polar covalent bond. This is basically the bond that makes up water. And what happens when you have polar covalent bonds is the electrons are sometimes more attracted to one nucleus of an atom rather than the other ones. And they spend an uneven amount of time around that nucleus, which means that that end is going to have a more negative charge to it because they're spinning around that much more often, so there's more electrons on one side of the molecule than the other. Okay? So polar covalence bonds cause atoms to have a negative pole, or a negative side, and a positive pole, or a positive side. Water is an example. So what happens is you can see here that hydrogen does not attract the electrons as strongly as oxygen. So what happens is the electrons spend most of their time around the oxygen atoms, spinning and spinning and spinning, and then they go around hydrogen and spin and spin and spin, and then, all right, and then they spin more. They spend much more time around the oxygen atom, giving it a negative charge. Now, realize that that negative charge causes the polar molecules to be attracted. So you have the charges that attract to each other. Okay, and that's why that's what gives water a lot of its properties. Its properties of adhesion and cohesion. Water molecules are cohesive, meaning they want to attract to each other. Okay, they're also adhesive, which means they want to attract to other surfaces, and their polar charges are what really cause that. Okay, so here you see what more better drawing of it in the Bohr diagram structure. You see the electrons spend most of their time around the oxygen atom. Okay, so the oxygen has the more negative side, and the hydrogen the more positive side. Okay. Okay, that's the end of today's discussion. Please write down any questions that you have. What you should be doing as you watch these videos is writing down questions and coming in and discussing it in class. That'll allow us a more personal explanation of what is going on in chemistry. Okay? So please take the time to write down any questions or any misconceptions or things you don't understand, and come see me. And as you're working on your notebooks and on your labs and other activities that we do in class, you can ask me questions. Okay? Have a great day.